seen this contraption before. This is a American rotary shock absorber dyno, and you'll see that when we turn it on, it makes the lights dim. As it goes up and down, the lights go. It's got a massive DC drive motor in it, and we had to get the power upgraded to the building to run it, believe it or not. It made the car club's lights go. So the way it works is that it's got an eccentric in here, and it just drives the shock absorber up and down like it would be in the car, and it's got, a load cell here. So what it enables us to do is to mimic what's going on in the car, and we can change how fast we have it moving up and down, and we have various different templates set up to be able to mimic the speed, and it self-diagnoses the temperature, so you can set it so that it warms itself up, and then it'll run, and I'll show you how that works in a minute. So these particular conies we've got here, they're pretty good shock, and the two adjustments are these little barrels in here with the little holes in them. I need to find out if I've got the right tool. What we've got is a bump and a rebound, and if you could just have a look on there, you can see it says bump, rebound, so the top one's the bump, the bottom one's rebound. And if you move it this way to the minus, you move it with a little Allen key, that way to the minus makes it softer. If you move it the other way, it makes it harder towards the plus. So there's normally 12 positions in a shock like that. Okay. So what this is going to do is when I turn it on, it's going to go up and down slowly to start with. And what it does then, it diagnoses the gas pressure inside the shock absorber. So it checks that it's got the correct pressure in it, and if it hasn't, it comes up with an alarm because the shock won't work properly then. So once it's happy that it's got that shock pressure correct, it'll then go up and down a few times until the sensor says that it's at 15 degrees or whatever you've set it at, and you can have it set at whatever temperature you want. And then once it gets to that threshold, it'll go off and do its run, and then it'll give us a graph. And as you can just see, there's two runs there. You can just see two very slight differences there. So this is the bump curve, up and down, and this is the rebound curve. So we've got force this way, and speed this way. Okay, so if I go, no absolute exit with this, so if we go like this, these are the two runs we've done before, and we go down here, so start test, okay. Tells you it's going to start, so stand back, put your high vis jacket on, and there it goes there, start. It's just checking itself. Okay, so then we can just go save there, and you can see there it's put another, see it's put another line in there. So that's the difference between when I checked it just before you guys turned up and now. So the ambient temperature still, we ran it a couple of times first, so it was a wee bit warmer probably than it is at the moment. Yeah. So that's how, that just gives you an idea as to, I mean, if you look at the height of this, this is force, so this is 50 kilograms force here. So between there and there is 50 kilograms. So we're talking about the difference of, I don't know, maybe 8 or 10 kilograms of force difference, just because the temperature's changed a little bit. Just excuse me for a second, I'll go down and get a thing and I'll make an adjustment. We'll see.